So in section 4.7, we're going to be looking at what are called coordinate proofs. Um, it's not a great name for it. What's happening is in coordinate proofs, we have to work on a coordinate plane to prove something is true with deductive reasoning, but it's not going to look like any of the proofs we've done before, and that's going to kind of come as we go through this series of videos. The first thing I want to talk about is just placing triangles on a coordinate plane. Uh, And the reason we want to do this is, I know you can graph points, but when we do coordinate proofs, because we want it to be generalized, a lot of the times we don't actually know the size of our triangles. We're given generic things like, oh, it has a side that's k units long, or it has a height of h. And how do we graph that? So we're first going to start by just having some that are already drawn on a coordinate plane and from information figuring out what its coordinates would be. Then we'll practice actually placing them on the coordinate plane. And then finally, we'll actually do a proof using one of these drawings on a coordinate plane. So some tips for when we want to graph something on a coordinate plane. If we can use the origin either for the center of the triangle or for the vertex of the triangle, especially if it's the vertex, that is a huge help. I'm a big fan of using the vertex for putting one of my vertices of a triangle on the origin. Secondly, if we can put at least one side on an axis, ideally, if it's a right triangle, we can use both axes. Third, try to keep it in the first quadrant, mainly because it's just easier dealing with positive coordinates than negative coordinates. Uh, and then finally, you want to try to pick coordinates that are as simple to use as possible. This will make more sense when we get some examples, but a good example of this would be if you need to find a midpoint, use multiples of 2, because when we find a midpoint, we're going to have to divide by 2 at some point. So if we make something a multiple of 2, it's so much easier to do that division. So some examples here. Here, I have a right triangle on here. Oh, I'm sorry, an isosceles right triangle, QRS. Now remember, isosceles means that the two legs are the same. So that means that hypotenuse is always the longest side, so these will have to be my coordinate side, my congruent sides. Q, I can see that Q is at the origin, so Q's coordinates are at 0, 0. They tell me R is at C0. C is a variable. We don't know what it is, but it represents the x coordinate. And what's nice about this is it means that this distance from Q to R, because I'm traveling along a horizontal axis, it is C units long. Well, that means because segment SR is congruent to that, this also must be C units tall. So if I'm moving up, my x coordinate doesn't change, but my y coordinate, I need to go up C units from 0. So this will also be C. And there are my missing coordinates. I admit I would not have done my isosceles right triangle like this. I would have done my isosceles right triangle like this one, in that I have my axes. Here is my isosceles right triangle. The hypotenuse is always the longest side, so that means that AC and BC are the congruent legs. Here's my right angle. Well, C is placed at the origin, so C is at 0, 0. B is at the coordinates I'm told of D0. So what that means for me is this distance is D units. So if D was 7, that's 7 units. But because AC is congruent to BC, this must also be D units. So if I'm moving up from 0, 0, the x coordinate's not changing. The y coordinate has to be D plus the 0. So I have D. So A is at 0, D. Where it gets a little bit tougher is, say, here. Oh, I forgot to put my vertices in here. I'll say this is D, this is O, this is G. And this is a right triangle. So I can see that my right angle is here at D. I can also see that D is at the origin, so D is at 0, 0. Ignore the tick marks because I don't actually know any of the lengths here. If you notice, I did not put any scaling, so I don't know what each tick mark represents. I could be counting by ones, I could be counting by halves, I could be counting by tens. So I don't know how long DG is. So what I do then is I just pick a variable. Please try to avoid X and Y. That tends to cause problems when people are looking at it because we're used to coordinates having X coordinate, Y coordinate. I recommend picking from near the beginning of the alphabet. So I don't know how long DG is, so I'm going to say, well, it's A units long. Well, if it's A units long, and I move from D to the right, that changes the X coordinate, so 0 plus A units is A. I did not move up at all, so 0 for the Y coordinate. So G is at the coordinates A, 0. For the length of OD, I don't know how long that is either. I don't even know if it's the same as DG because I don't know if this is isosceles. So this is another unknown value, which means I need a variable. But because I don't know if it's the same as DG, I have to pick something that's not A. So I'm going to say that, whoops, this is B units long. So that means if I move up from D, the X coordinate does not change. The Y coordinate, I do B plus 0. And O is at the coordinates 0, B.